Good afternoon. This is Gail Ogletree, ACD's Coordinator of Education Programs, and I'm pleased to welcome you to today's webinar, Dispatch for Chemical Fleets, Applications of Automation and AI to Manage Risk, Compliance, and Efficiency. Thank you so much for joining us. Before we begin, I would like to thank today's webinar sponsor, Ritex, for sponsoring this webinar. Thank you for your support of ACD's educational offerings. I have just a couple of housekeeping items before the program. To minimize background noise, your lines are muted. If you have questions, please type them into the question or chat box on your screen. We will address them in the Q&A period following the presentation. If we run out of time to answer all of your questions, we will follow up after the session. Today's webinar will not exceed 1 hour, including Q&A. We are recording the session and will provide you with the slides and the recording within the next few days. Following the webinar, we will also send out a brief survey. Please take a few minutes to fill this out and return it to us. Your input will help us to plan and improve future sessions. Please be aware that all discussions during this webinar are off the record and not for press coverage. External recording of the webinar is strictly prohibited. We are making a recording of the session available to members in the coming days. Thank you for your cooperation. It is now my pleasure to introduce today's presenters, Hans Galland and Natasha Martinez. Hans serves as the CEO of BeyondTrucks. Prior to founding BeyondTrucks, Hans has built operating, finance, and technology companies in logistics, hospitality, and real estate. He has deep experience in bringing operational improvements to complex traditional businesses, leveraging technology, people, and cultural change. Some of his success stories, including building and scaling JLL into China's largest hospitality consulting business, transforming asset manager Pacific Eagle into a $1.2 billion real estate development business, and turn around complex operating businesses. Hans has served on numerous for-profit and non-profit boards, including Lucid Motors, Newhouse, Holistics, Global SF, Mirakind, and the San Francisco DTNA. Natasha serves as the head of customer service, overseeing all customer implementation, onboarding, and training. She previously managed 3,000 plus drivers and implemented legacy TMS systems in various executive positions, such as National Vice President of Transportation at UNFI and Corporate Vice President of Transportation at SuperValu, after holding various senior management positions in transportation and logistics at CNS Grocers. Natasha is a skilled operational leader with the talent for strategic planning, process and quality assurance, team building, and P&L oversight. Her talent to zoom out from tactical execution to strategic insight and planning takes her from the loading dock to the boardroom. I will now turn the presentation over to the BeyondTrucks team.
Thank you, Gail. Thank you so much for having us. I'm very, very glad to be here with Natasha. So today's topic, what we'll cover is dispatch for chemical fleets. Chemical fleets is one of the segments that BeyondTrucks is deeply specialized in. And we'll cover how automation and artificial intelligence application can improve risk management and the efficiency of fleet operations. So what we'll cover today, some of the errors that we see in operations of chemical fleets, compliance issues, the actual root causes of these errors, and how new technologies can present opportunities for us to improve these on these operational challenges. We'll talk a little bit about the limitations of AI and automation, something that people oftentimes don't talk about, but I think it's very critical to understand. And then we'll cover some case studies if you have sufficient time for that. As Gail mentioned, we'll cover questions mostly at the end. There's some interactive parts of the presentation, but we certainly welcome a lot of questions, and we'll leave some time at the end. A little bit about BeyondTrucks. BeyondTrucks was founded in 2019 in San Mateo, California. We serve fleets across the United States. We have a team of close to 50 people that really includes people from 3 distinct disciplines. We have folks with very deep operational experience, such as Natasha, people who have run fleets, operated in dispatch, have operated large driver bases, and like Natasha, bought many other fleets and implemented technology across them. We obviously have software engineers. We're a software company, but we also have data scientists and machine learning engineers, which is a discipline that the traditional technology providers often haven't had in the past. So interesting animal as a company and as a team. One of the interesting things, if you look at our team, is we are very thesis driven in how we approach the company, the industry. And one of the observations when Paul, my co-founder, and I, who has a background in artificial intelligence and AI chips, when we sat down, we recognized that one of the unique things that's happened over the last 5 years with fleets is the digitization of the driver end of fleets. So the fact that fleets are now real time with the ELD mandate, connected, and increasingly real time, transmitting data from the telematics in the truck, but also from the cab, where the driver interacts with a tablet, is now not only practice in some of the large fleets, but is by and large industry practice because the ELDs have really digitized that part of the operation. And it's been digitized with technology that is SaaS, that's multi-tenant SaaS, and that integrates via APIs very easily into other technologies. But the challenge that we see generally is that the underlying core technology, the core transportation management systems, oftentimes hasn't evolved and is architecturally still living either on an on-premise server or in a private cloud. So with that came a lot of opportunities that we saw pain points in operations that create issues for fleets, operational issues, and that really motivated us to create a company that re-envisions the software stack and the opportunities that come from that with automation, artificial intelligence. So that's a little bit on the company. Let's talk a little bit about issues, and I asked Natasha to really jump in and provide examples, real life examples from some of our customers when we go through these, when we look at errors and compliance issues. So some of the most frequent calls we get is usually from a customer when they have issues, when they have errors, and they realize that the underlying issue was related to technology. So calls that we get is, for instance, are around documentations. It could be a BOL, it could be a POD, it could be payload records. We frequently have carriers that could be, motor carriers who charge their customers based on the tonnage that is delivered in a bulk chemical scenario, for instance, right? And sometimes these payload records are wrong, and if it's a for hire carrier that's under invoicing their customer, that may be involve millions or a couple of hundred million, tens of $1 million in lost revenue. That same thing could happen when you process payroll based on certain records that are captured in the delivery process, and you are overpaying your drivers or you're underpaying your drivers, and the drivers leave you. So issues around documentation in the delivery process typically create challenges for fleets. Low driver tractor assignment error. So this is the fact that the wrong driver is hauling the wrong type of commodity with the wrong type of equipment. Could be a liability issue. It could be an endorsement issue. It could be a compliance issue, but it can also be just an efficiency issue that you're spending too much gas or diesel on empty miles, for instance, right? Trailer wash errors. There's a lot of inefficiencies usually in chemical transportation around poorly optimizing on trailer washes. The best people usually are dispatchers who've done it a very long time, but trailer washes obviously combine potential contamination issues with just efficiency considerations on which trailer should be washed, and which trailer should be assigned to what load. Errors that we see in loading, unloading, QA, just safety procedures, just procedural steps that in the past you would have an operating manual, a standard operating manual or SOPs, or you would have trip sheets that the driver or someone at a facility would fill in. And because it's paper-based, because it's based on a trust or a training basis, that the enforcement of those procedures may be lacking and creating safety or compliance issues. And then lastly, unsafe driving practices. We have that in all types of fleets, or kind of failure to adhere to routing and scheduling requirements. We see that oftentimes for instance, with hazmat fleets, where the driver is deviating from a hazmat route for a hazmat load, and that obviously can create issues and compliance issues. I don't know if Natasha has anything to add.
Yeah, I think one of the things is we can continue to list all the different errors. And I think the biggest thing that the team needs to understand is that legacy platforms that were used in the past, whether it was handwritten Excel spreadsheets, SOPs, handwritten trip sheets, or an actual TMS that you may have used in the past, they were all segmented just to kind of hold product and hold data. None of them really linked together. So, for uploading a bill of lading, maybe something as simple as exactly what you're showing here. Driver has all of his paperwork. He usually has a nice clipboard that opens up and keeps all his paperwork in it. And then, in some instances, they may be taking a picture that goes out to this system, and then somebody in the back end is trying to go then find them and what we call, put them together. So that's kind of where those errors start to come across from. It could happen at multiple stops because there's multiple people touching that information, correct? So it could be a driver, it could be a dispatcher, it could be a data entry clerk in the back end trying to key it out in the back end for you as well.
Yeah, I think one of the critical things that we observe in many, many fleets is that the tools that are being used are data record tools. So if you think about, a trip sheet, that's really a data record tool. Most traditional transportation management systems, and if you look at the screens here, this is very fairly traditional. It's probably some sort of a TL2000 or something. They were built as, we sometimes call them jokingly, digital filing cabinets. They are there for someone to enter an order or a load, and they're there for someone to issue an invoice and calculate payroll. But they were not built to actually manage processes. So what we see in many fleets is the processes, the workflows that are run across many different types of technology, right? It could be document scanning, TMS, accounting, trip sheets, Excel, Google Sheets. Google Sheets is probably one of the worst tool to run a process. It's actually just
definitely
a database, right? So I think what we see with that, the problem is you have this chimera of stitched together solutions that fragments your data and it fragments your processes. And as a result of that, for things not flowing, the information doesn't flow, your workflow doesn't flow, you find errors in that because things get missed or don't get translated.
Right. And it makes no source of the truth, right? You don't know where, you have no idea where to go back to look to say, was this data real? Is it right? Because most of what's going to happen is they're going to go back to that piece of paper that somebody filled out somewhere to say, oh, wait a minute, I keyed it wrong. Or, oh, wait a minute, I took the wrong picture. So, yeah.
So in many fleets, we see this interesting scenario where the data is captured in many different silos, but then sometimes from corporate, sometimes from the CEO, sometimes from a very creative CTO, or for whatever reason, we get inquiries and say, well, we want to run AI or machine learning on my fleet. And that usually is a big conflict with the actual ability of the data that has there's so many different sources of the truth. Now, the very, very large enterprise fleets typically find a way to deal with it. And what we see, once you get into a couple thousand driver fleets, you will have professional data engineers, professional data software engineers and data scientists on the team, and you can stitch it together. But if you're a kind of smaller or mid-sized fleet up to 1,000 or 2,000 drivers, you may not have those resources to actually deploy these solutions in your team. So what are the sources of errors? It's usually lots of manual data entry in disconnected systems, repeat data entry oftentimes. It could be basic calculations. Errors also come because people, especially dispatchers, may not have complete information. They may have insufficient information. It could be from reliance on tribal knowledge. And if the person with tribal knowledge happens to be in the hospital a day, the new guy who comes in and is trying to step in for the day, you may actually miss things. And then there's also errors that happen for a concept that's known as bounded rationality, which is when you have to take decisions really, really fast, your decisions tend to be biased. There's a great book by two behavioral economists. Some of you may have read it, called Thinking Fast and Slow. And if you know how load planning or dispatching happens, it happens in a very, very fast-paced environment. So, it is fair to assume that even the best dispatchers has biases in their decision making that mathematically may not make sense, but they may be biases. So there's a number of reasons why we have errors in this, and they're usually human errors. Here we go to kind of a little pop quiz that we put together. What do you think are the error rates for manual data entry? So these are samples that these are experiments that are run in large data entry facilities, probably in India and Pakistan. But if you could put into your chat window, what is your estimate? If someone puts, just keys and data, what is the percentage of errors that you have in manual data entry? Maybe some people can put something into the chat window. I can see the answers. I don't think you can see the answers, but if someone wants to put a wild guess out there, feel free to show that. If you have anyone willing to risk it. Maybe I'll
Correcting my manual entry is always correct.
Yeah, so maybe let's run through this in the meantime. So just for pure manual data entry, what we see is that about 1% of data that's entered is typically incorrect, and that's happened in large data processing facilities. If a task involves basic arithmetic, statistically what we see is that 3 to 5% of the basic arithmetic calculations are just wrong. It gets even more interesting with spreadsheets, our good friends, the Excel or Google Sheets. So when a spreadsheet has at least 10 formulas, the error rates are about 18 to 40%. And if a spreadsheet has more than 100 formulas in it, typically the error rates are 87 to 99%. And that's a really important fact when we want to run, tight processes in an organization. Definitely. Where we are relying so often on Excel.
Well, we had to think a lot about, you may look at this and think 1% is not that big. But when your margins are small, if your margins are, 3%, that 1% is a lot when you're thinking about it over and over again, especially depending on what you're keying and how much manual data entry you're actually doing. Is it on the invoicing portion of it? Is it on the driver pay? It could be 1 cent a mile, and that's a massive impact on a customer.
Absolutely.
Yep.
And then, sources of errors can also be processes. So switching from analog to digital, we see that a lot. So someone putting something into a paper form and then entering it into a system after. Happens a lot in private fleets. We see that very commonly in private fleets where, trip sheets are still commonplace, and then they get handed over to accounts payable for payroll or accounts receivable for internal invoicing, and we see that very, very frequently. Disparate information flows. We talked a little bit about that data doesn't seamlessly flow, and then human verification. Traditionally we see fleets use layers and layers of checks, which is the natural thing to do, but even checks can fail. So we see errors as a result of human checks sometimes. So let's talk a little bit about how we can fix these things and what exists. So new technologies that we see offering opportunities, and I'll just run through them basically, and we can talk a little bit more at concrete examples. But integrations, which is actually, some people don't think of integrations, is actually an automation technology. It's something that automates data flows and connects to different systems. And in many parts of the economy, APIs are commonplace today. In many organizations, they are. But what is important to understand is that APIs have made it much cheaper to connect different systems. And that is valuable if you think about how to construct assemble different technologies. About 20 years ago, it was much more commonplace to buy one system that does everything, because integrations were extremely difficult to maintain, primarily because your software lived on different servers. So the integrations required one engineer to connect two softwares on two different servers, possibly, to connect them and maintain them. Today, with things being in the cloud, you can actually connect architectures rather than individual software instances. And that makes APIs extremely powerful and cost efficient to automate data flows. So integrations are a very critical thing that we pay a lot of attention to. when we implement dispatch technology. Rule-based automation is an automation function that we deploy. In some instances, we could look at some examples. It's essentially hard logic that you can define. So, for instance, if customer requires a pump for unloading fuel at a facility, then the only qualified or suitable tractor is that tractor that has a pump. That could be a rule-based logic that we would accommodate in a dispatch software like ours. Large language models, everyone has heard about ChatGPT. There are new applications for large language models for language-based tasks in transportation. We'll talk a little bit about that, where that is particularly in document processing. We see a lot of opportunities for that. Machine learning based logic, we'll cover some examples. So learning from past behavior or past patterns, and then projecting forward how that could be relevant in the future. Or then reinforcement learning, which is a type of machine learning that solves for a optimal outcome, an objective function, as we call it technically, and in which the outcomes then get scored in a feedback loop to improve the learning process. So there's usually a learning process involved. So reinforcement learning is something that we use particularly in optimization type tasks. These technologies can be applied for pure automation, but also for optimization and automation. Optimization obviously has a particular goal in mind. So we'll cover some examples of how we've seen applications in actual use cases. And Natasha will take a little bit more of that presentation, but some examples can be we look at where we see errors, could be quantity conversions and rates. And Natasha, I'll let you cover that one for a little bit.
Yeah, and again, so the difference is there's all types of different things, especially when you're hauling chemicals in bulk, of how maybe your driver understands. Let's say you want your drivers to put it in as gallons or pounds, but your customer wants to see it in tons, and there's a conversion. So that goes back to right before we talked about the manual data entry and the basic mathematics skills behind that. And if you have someone that's always having to do that and go back in there and key it, then that causes an issue and can have error rates, which go back into either if you're paying a driver based off quantity loaded or unloaded, whether you're paying, invoicing your customer based off of quantity the same way. So in our instances, we can actually do that conversion for you. So we can easily say the driver wants to put in that he's loading X amount of pounds, X amount of gallons, and then we can do that conversion for you to convert it to what the customer wants to see, whether it's turning it into tons or not.
So that's an example of
avoiding a lot of that mathematical issues.
Yeah, so this is no rocket science. Obviously, this is basic rule-based automation. But if you think about failures in your organization, there may be some examples in dispatch that, especially on the driver end as they collect paperwork, where these can be the source of issues. Here's another one that we see very frequently, issues and that's actually entry of load data or order data. So in many cases, that order data could come in as an Excel. It could come in as a PDF into a transport operation. And so one way to automate it is to actually digitally read these files in an upload through an upload function. So for instance, we read not only Excel spreadsheets, but we also read PDFs, or we could technically read emails. We could read emails that get sent out from inventory monitoring facilities where silos monitor product or commodities that accumulate in a silo, and we would trigger haul-off activities from that. So there's a lot of opportunities to automate at the order and load creation level that removes the human error that comes from maybe not correctly entering data, or also just not being aware of data that a load has arrived. For instance, we have one carrier, maybe we'll talk about them later. They had significant amount of errors because they actually manage their order entry process in an email inbox. So the customers would send them emails, and their rule was if someone had opened that email was taken care, if that load was taken care of. But if the load was not taken care of, that email should show up as unread. And that obviously is a kind of a basic rule, but they lost significant amount of business because they missed loads through that process significantly. So that's something that there's not one way to automate load and order entry, but it's certainly one area where we see a lot of opportunity for automation to avoid errors. I'm going the wrong direction here. Inventory monitoring, Natasha, do you want to cover that a little bit? We talked a little bit about it.
Yeah, sure. So again, you kind of talked a little about this. Can be either silos, this can be different types of inventory. So specifically for this example that we're showing, it's actually for fuel, and they're actually monitoring gas stations. And what we are actually able to do is, instead of going out, what they were doing is going into each individual gas station and looking at the different levels, reading it once a day, and we'll kind of go into more detail. What we're actually able to do is go out and scrape all of that data real time, multiple times throughout the day. In some instances, it's real time data, depending on how often those tank readings are read to us. And then what we do is we actually show a list, and you can see kind of examples of, we do a list view. We can also do a map view. We also did color coding based off of what the customer thought was, red, green, or yellow. Is it good? Is it in need of fuel right this moment? Is it getting close to where their reload inventory levels are at? So this again gives them one big view for every customer that they're monitoring at a split second, versus having to go and have multiple different spreadsheets in their example. But in other examples, you'll have to be able to go into every single one of your customers that you're monitoring. So this gives them one unified view here.
So
go ahead.
Yeah, one important source of error. There's two sources of errors that we find in inventory monitoring. A is basically capturing the inventory data as real time as possible, and sometimes they forget. Customers forget, fleets forget checking on inventory levels, and so that's one. The second one is actually accurately projecting consumption. So as you know, a reordering happens once you reach a reordered point in your inventory, but to project how early the truck needs to leave and to deliver fuel in this instance to an underground storage tank, you need to understand consumption, the pace of consumption of fuel, and in a silo, maybe the pace of production, and so forecasting consumption levels is actually by itself a great application of advanced analytics, such as artificial intelligence, or sometimes maybe just a pure regression analysis. But there's certainly advanced statistic methods that can be applied and embedded into this function to automate.
The other thing we can
eliminate error.
The other thing we also can show that you can't necessarily always check when you're manually going into one of these is to know whether or not the fuel monitoring system at that tank is actually working or not. So the other thing we also show is that there's been no new data provided. So we tell them this is the last time where we got to read, and here's the same reading at the same time. So this way it gives that dispatcher or whoever's looking at it, they know, okay, wait a minute, there's a problem at that tank specifically, and then they can be proactive about notifying the customer as well.
Okay. Compatibility checks. Natasha, you want to talk a little bit about this, how we see errors on compatibility and how automation can help?
Sure. We kind of talked about this a little bit earlier about errors. So you use an example of about a pump. So let's say that you have a customer, we have different scenarios. Let's say you have a customer who does require that you bring a pump to be able to pump off. And you know that this trailer has to have this truck to be compatible to be able to have a pump. But you also want to know, is that driver certified to drive that piece of equipment and use that pump? So what we actually do is a couple of different layers. What we can do is when you go to an assignment, it'll pop up and say, this is a piece of equipment you should be using. This is the trailer that should go to it. And when you go to assign that driver, it will pop up and tell you whether that driver is able to use that equipment or not. And we do that based off of a couple different things. So under driver profiles, we have what we call qualifications, and that can go down to levels, like I said, pump. It could say maybe this driver has a TWIC card. It could have different layers of whatever your requirements are. And then as that dispatcher is doing the dispatching or assignments, we kind of help guide that dispatcher. So think about it now versus if you do have 1,000 drivers. Instead of a dispatcher who may be new coming in and saying, okay, I don't know this location I'm going to, but I do know that it needs a pump. Let me put it on this driver. They're looking at now 1,000 different drivers to choose from. We limit it down to the drivers that are capable of actually hauling that type of equipment, that type of product, or have qualifications. Even things as much as, is their MVR up to date? Do they have all of their different certifications up to date? So we narrow that down to make the error from here to very limited ability for that dispatcher to make the right decision.
And this is kind of an interesting example because I know we have a couple of safety folks in the audience. So this is really enforcing safety at the operational level through the dispatcher. And I think you know, safety doesn't happen obviously in isolation. It happens in all parts of the organization. But there are automation tools, and this is again, it's not rocket science, it's very basic rule-based automation that can help flag compatibility or incompatibility and, you know, avoid some of the very risky or dangerous decisions or mistakes that a dispatcher could make.
Because usually what you'll see is they'll have an Excel spreadsheet with the list of drivers that have different qualifications, and then they're working in this one system, and they don't show up together. You're having to compare different worksheets together to make a good decision.
Yeah, this is just an example of how it looks actually in a platform as you assign and things get highlighted. Digital driver workflows. So driver workflows is actually an opportunity where we see a lot of an area where we see a lot of opportunities for improvements when it comes to both managing compliance and safety. As I mentioned, I think the biggest change that we've seen on driver workflows is today, almost all drivers have a tablet in their cab through which driver workflows can be coordinated. And because the ELD required the drivers to, the ELD mandate required drivers to adopt the tablets, they're actually using it. So I think there's a new interface available to interact with the driver and embed incentives or forcing functions to have the driver complete certain tasks and provide evidence of certain tasks, like, you know, checking a pressure gauge, checking a temperature reading, a thermometer reading, taking a picture of that. So there's things you can force the driver to do through these driver workflows. So because there's a new interface. The second thing that is unique is that in the past, there were driver workflow technologies, but they typically had to be integrated separately into the main transportation management system through a complex service, usually with a service provider who would connect the two softwares. And it generally didn't work very well together. Today, most of this, what we're talking about, is actually delivered natively in the transportation management system through then either the ELD tablet function or a private app that is available through BeyondTrucks. But the result of that is that certain driver workflows can be triggered based on certain conditions, right? They could be triggered based on a certain type of commodities hauled, for a certain type of time of delivery. It could be a certain location. It could be a certain destination, a certain customer, and that builds essentially allows you to take your, you know, in the past an SOP manual and put it into a software that requires the driver to complete everything according to SOPs every time they haul a load. And so that's the new opportunity that we've seen significant traction. There's companies like Samsara on the ELD side who are very good with that if you can successfully connect it with a TMS. So a great opportunity to standardize, avoid errors, in safety incidents with driver workflows. Some of the most progressive fleets today tie this compliance to these driver workflows directly back to driver compensation. And then, it gets paid bonuses based on obviously adherence to these workflows. So additional, both carrots and stick approaches usually work pretty well on adopting these driver workflows. Natasha, any other thoughts on that?
Yeah, I think the big thing you just said it right then was the driver adoption of being able to use workflows. Today, in most instances, the template is the same template for every driver, no matter what that driver is hauling. And so what happens, they usually bypass a lot of those things because they're like, okay, I don't do that, I don't do that, I don't do that. So the workflow of what a driver needs to do if he's hauling jet fuel is completely different if a driver is hauling a different type of chemical. So you want those workflows to be specific, and you want it to be that way the driver is doing exactly what that driver needs to be doing, and not extra fluff that they don't want to do, which gives them harder time to adapt the workflows.
Great. Trailer wash. Natasha, you want to talk a little bit about that?
Yeah, same concept, kind of going back to some of the driver workflows. In some instances, drivers, you want the driver to verify that the trailer's been washed, or maybe that you want it to know that the driver washes it afterwards. Or you want some logic in the back end that says, okay, for the last 7 loads that I've had, now I require a wash. It could be all types of different logic. It could be top loading logic, meaning this chemical on top of the next chemical. It could also just mean as simple as you want your requirements to be that you want trailers washed at every 2 days, 3 hauls, every load. We help build in that logic in the back end for you. And that logic, again, can be specific to the type of trailer, the type of commodity. Because again, if you're paying for the trailer wash, you don't want to wash every time if you're hauling the exact same load, exact same type of commodity. You want to only wash when it's the right time. And then again, it can be tied to, if you're charging things like that as well. And you could put again, put it back on the driver to validate, verify, and then ensure that it's all been completed.
Great. I'll talk a little bit about one of the more advanced topics for automation and artificial intelligence application, and that's dispatch planning, or some people talk about it as routing or scheduling. And one of the things that we see is we obviously have many fleets that apply routers or routing algorithms in the load planning process. Generally, in that process, what we challenge the fleet owners, or question the fleet owners, is what are you optimizing for? Many very important questions for anyone who manages this is to get clarity on how the router actually works. We have seen many customers who actually don't have clarity around what they're optimizing for. Is it empty miles? Is it total miles? Is it minimum cost per mile? Is it maximum revenue? Every fleet has a different logic, but the routers typically are fairly generic. The second thing that we always question fleets, is it actually working? No one actually knows in most cases. So routers are usually very, very challenging. And the last thing that we see a challenge in is actually adoption. Is that the router says, here's the perfect route for these loads to be stitched together, and then the dispatcher looks at the route and says, hey, this doesn't make any sense to me. Or, I'm putting driver Frank on this, and driver Frank doesn't want to go to Denver, so I'm reconstructing the route. So generally, we see kind of a gap between the recommendation from the router and the actual operational practice in the field. So that we call that a manual override. So generally, that's some of the challenges. Now, AI and machine learning actually offer some new opportunities in the space of dispatch planning, where making wrong decision, making errors in dispatching can be costly for the organization. And so the way we look at it is, rather than thinking of a standalone router, we actually think of optimization really as a kind of a co-pilot function, where the dispatcher or the load planner is in the driver's seat and gets assistance from a machine in that process. In our case, that function is actually native in the TMS. It's not a separate software, but it actually lives or is embedded in the TMS. So much so that it is very present in the actual workflow of the dispatch and the assignment workflow. The problem with the old way of dispatch algorithms is that typically they rely on some sort of a database. The problem with a database is it's usually never comprehensive enough to reflect reality. So it may or may not include, the latest weather data. It may not include driver preferences, or driver preferences may change. They may include a lot of things that the dispatcher actually knows, but that may not be captured in a database. So that's one of the reasons why sometimes these manual overrides by the dispatchers are actually right, because the dispatcher has better information than the algorithm. So in our case, how we look at it is actually that we rely first and foremost on dispatcher behavior in the past. It's kind of the baseline to look at route optimization. We assume that the human capacity of routing manually is actually pretty decent. It may not be perfect, but it's a good starting point. And so by starting with giving credit to the human dispatch capabilities, we say, well, let's learn that behavior rather than defining a bunch of roles in an algorithm that says this delivers you the optimal outcome. We say, let's believe the human is good at dispatching and learn from human dispatch behavior. We do that with machine learning algorithms where we study, maybe 4 or 5 years, maybe 2 years of dispatch data, and then project that dispatch behavior into the future, into a future scenario when a new load comes in. And then we layer on top of that and what we call an objective function. So we layer kind of into that algorithm a function that defines this is a desirable goal to optimize towards. And then rather than the dispatcher getting one suggestion that is the optimal outcome, in our case, the actual dispatch behavior of accepting or rejecting or tweaking that dispatch recommendation in turn improves the algorithm. So in our case, we believe that the future of dispatch optimization is one that gives a lot of credit to the actual dispatcher's knowledge, improves on the past dispatch behavior, and then learns again from the human dispatcher how they've tweaked the optimal suggestions to the dispatcher. So it's a real great interactive interaction between human and the machine capabilities. So that's one of the areas where we see great opportunities to apply artificial intelligence to automate, to streamline the dispatch processes. You can dispatch much faster, but also to improve dispatch outcomes. Okay. So here's an example of, and primarily a dispatch optimization automation and optimization algorithm. So here in BeyondTrucks, that gets specified, and a recommendation gets presented to the dispatcher that the dispatcher then could tweak and adjust based on their own experience or their own knowledge, that then again in turn improves the performance of the algorithm. So I'm just leaving that for everyone's observation. Good. So to sum up, as I think we have covered a couple of applications of artificial intelligence and automation in the dispatch process, automating order generation, extracting information from paperwork or PDFs or Excel, automating compatibility checks with against driver endorsements in hazmat, for instance, or equipment compatibility, standardizing driver workflows, ensuring correct data extraction and validation. And then, of course, we talked in the last instance about dispatch automation and optimization. So a lot of applications in the dispatch process for these. Now, what are some of the limitations of AI and automation? So I think generally automation, especially if it's rule-based, is quite risky because it's a default rule, and the rule may or may not apply to a given situation. So it becomes challenging if you have to manage exceptions. So we use rule-based automation if it is acceptable that a rule is applied incorrectly. For a rule, sometimes a rule needs to be definable. We have situations where customers define a rule but never think about the exceptions. And then we run into issues. So it's one of the challenges with rule-based automation is exception management. Limitations of AI, we talked a little bit about that in the traditional dispatch routing algorithms, is human override. So humans may need to be able to override, or sometimes should not override. So that dynamic between the human and the automation is challenging. And I think we find the best dynamic between kind of having an automated solution and then the human to interfere to avoid issues sometimes is usually reinforcement learning that bridges beautifully between the human and the machine capabilities. Many AI applications just present you with results, but they don't really present you how they got there. So we call that the black box issue of AI applications. So sometimes that may create an issue. It could be an issue in liability cases, for instance, if you need to document how you came to a certain conclusion. The black box nature of an AI application may not be appropriate. And the last one is one that's talked about a lot with large language models is hallucination. So if you use ChatGPT may just make something up that may, based on language logic, may be logical, but based on common sense may not make sense. So hallucinations is essentially the algorithm making things up that are not actually true. And that's one of the biggest issues with some of the large language models becoming better and better. Lesser issue, but it's certainly something that we are, as a technology provider, very, very concerned about, because the cost of an error is massive in chemical transportation. You know that yourself. If it could be the cost of simply the driver not going to Denver, but going to Atlanta, right? It could be a very high financial cost, but it could also mean a spill or a violation with the regulators. So I think one of the general principles we always use is before we automate, we think about the cost of an error in the automation. And with some of the applications of AI, they could be just massive risks. So rather than thinking about AI as an opportunity to just save on labor, we like to think about AI as an opportunity to avoid errors. And that's why we see in chemical transportation some of the biggest opportunities. How can AI actually help you validate and verify certain things? Okay. Natasha, do you want to cover the case study very briefly? Then we leave some time for Q&A.
Yeah, I know we have about 8 minutes left on ours. So I think this will be a perfect one. So we can talk a little bit about JP&N Transportation. So if you're not aware who they are one of the largest fuel haulers in the New England area. They have about 300 plus drivers, a mix between W-2s and 1099s. They are using a legacy TMS, which was called CSI, a lot of Excel spreadsheets, multiple whiteboards, which always everybody knows lives in any transportation office. Their challenges really were being able to dispatch trucks. There's a lot of it was all tribal knowledge. They did a lot of data entry. So all of their load building was manual, which caused a lot of different issues. They were picking up from different terminals with different suppliers, and it required PIN numbers. And so there was a lot of data entry in that as well. Load scheduling. So they were monitoring their gas stations. They would check it once a morning. Everybody knows those numbers change. They would have customers have gas wars next to each other. They had no visibility of any of that stuff. Their utilization of their equipment was also a struggle because they had multiple divisions and their trucks were actually driving right by each other. And they were just hard to see that because they were so siloed in how they were actually operating. They also did have some, obviously, a cybersecurity attack. This was an on-prem system, caused a multi-million-dollar ransom, major issues for the customer, including the gas stations that they were actually being able to fill. They could not get fuel back and forth to picking up at terminals or delivering to their customers. So in the next one, what you'll see is kind of high level. The top is what they were currently working with. The bottom is what it looks like today. So multiple spreadsheets of all of their different customers that they were monitoring their fuel systems for. And as we showed you earlier in the webinar, we actually have one unified look for them that everybody can see. It's also color coordinated. So very visual, very easy for anybody to walk into a room. The second part is you see the whiteboards. So in this example, they had these large whiteboards that are up in their office. As they would manually create a load, they would print out little small cards that told the dispatcher what to do, what driver was assigned, when to go, where, what terminal to pick up, and what store to deliver to, and at what time. Great concept. And we actually took that concept and actually transformed that. What was happening is something as simple as the magnet fell because these were small pieces of paper with magnets on them. Somebody would go up there to look at it, or a dispatcher would go take the card off, forget to put the card back on because a driver called or there was another fire going on that they were trying to help. So then you lose visibility. They were literally had stores that they had issues being able to service because the card never went back up on that whiteboard. So now what we have is we've made digital cards that they can actually move from one screen to the next. It's all touch screen. It doesn't go anywhere. If a dispatcher wants to get more detail on that card, they click into it, it pops open, they see all the detailed information, but every dispatcher can still see that that load needs to be moved. In the monitoring sections of it as well, what was happening is they would look at the load levels at their gas stations and then decide, like we talked about earlier, what was the consumption rate? Did dispatcher A create a load for that or not? And what we've actually done is we trigger based off of rules that says if those monitoring levels go to a yellow or go below a certain level, we actually generate the load for them. It creates a task and it requires somebody to do something with them. And then again, you just the different visibility of all the different siloed facilities that they have. Now they can see everybody in one section, exactly where they're going and what customer they're servicing.
The one thing we do typically with customers is quantifying the amount of errors and cost they have as a result of their workflows. And so in this case, this 300 driver fleet estimated that they have about $4.7 million in cost per year, resulting from disconnected systems and disconnected workflows. And the simple application of both automation and artificial intelligence technologies could actually save them about $5 million a year. So, significant. These numbers are not numbers we make up. It's actually the customer estimates using a worksheet that we've developed with customers, and so significant savings that we feel are material, especially given the margins of a typical transportation operation. So interesting to see when you actually put pen to paper and quantifying it. I'm going to skip the second case study and make sure that we have a little bit of time for questions. Please feel free to type in your questions that we could then respond to.
Great. Thanks so much for that presentation, Natasha and Hans. As Hans mentioned, we're now going to start the Q&A. So if you haven't already done so, go ahead and put your questions either into the question box or the chat box. We'll go ahead and start with the first question. How big of a difference does automation and AI actually make to a fleet, and how much ROI?
Yeah, so I can maybe refer back to the last case study that we shared. So in this case, it was about $5 million in savings. The transportation industry, if you look at just for hire carriers, typically sees significant savings on that are significant in relation to the margins they generate. Natasha made that point a little earlier. I think most of the private fleets that we work with, with distributors, so chemical distributors included, see the payoff usually on the customer satisfaction side, whether they can keep their customers happy or if they lose a contract, because that's usually the case why they have a private fleet. Or then, of course, the kind of outlier events of violations or chemical incidents. So I think it's a balance of risk management and and margins, but generally we see the opportunities to be somewhere between $10,000 and $20,000 per driver per year, which is material.
Where should chemical fleets start with some of these applications?
Yeah, I think it's data. We always say is start with the data. That may be in cleaning up your data in your system, but it may also be making sure that you clearly define where the source of the truth in your organization sits. And then you should start finding ways to integrate. One easy way to integrate is by integrating all the workflows, and that's what we typically do with it as a transportation management system. So connecting all the disconnected workflows and collecting data in that process. As I mentioned, large organizations typically build data clouds and have data engineers and applied data scientists to those tasks. If you can, that's usually the most important. But usually, your AI and automation applications only are as good as your data. And the second thing is interface, is making sure that your people actually use it and leverage it. And traditionally, people have been slow to adopt technology in transportation, but everyone today has an iPhone or an Android phone and is used to really, really good user experiences. And unfortunately, most of the transportation management technologies haven't really delivered that in the daily life. So I think user experience and data is really the important part that we usually focus on. Natasha, anything else you want to add? Where to start?
I'll be real quick. I think one thing to start off with is think about all of the different Excel spreadsheets that your teams are currently using right now and start there, because that's your first disconnect. That's their first show that you're having multiple spreadsheets with different people touching it and working in it. That's not uniform. So that's one good word where to look for. Where can you get all that information into one spot?
Perfect.
Well, that will conclude the Q&A portion of the program. Thanks so much to everyone for participating in today's session. And again, special thanks to Ritex for sponsoring this webinar. As a reminder, please look out for our follow-up email with the webinar recording, slides, and a brief survey. Our next webinar, Creative Solutions for Dead Inventory, Staying Out of RCRA, will be held on September 19th. Details are available on the education page of the ACD website. Finally, be sure to view ACD's news brief and Chem for announcements of additional ACD webinars on regulatory, responsible distribution, and business issues. This concludes today's webinar. Thanks again for joining us and have a great rest of your day.
Thank you.
Thank you.